Hello, welcome everyone. Today we are doing lenses and ray diagrams. So let me start with knowing what lenses are exactly. The lenses are actually the piece of glass or fiber that refracts the light. The main purpose of a lens is to refract the light, either by converging it or diverging it. And on the basis of that, they are further categorized into two types. Let me see, this is a lens. It's actually a piece of from a spherical glass or a spherical plastic fiber material. The main aim is to refract it. So what's happening here, when light rays falls on it, it converges. When light rays falls, it converges, and there it forms the image. If you remember, when we did the image, the definition of image, I said when the reflected or the refracted rays meet at one point, there the image will form. So image is forming after the refracted rays are meeting at one point. Similarly, if suppose this is another lens, in this lens also what's happening? It's the refraction happening. What's refraction? We already did. The refraction is actually bending of light rays. When it moves from one medium to another medium, from denser to low denser, or from lower denser to higher denser medium, then because the speed changes, so does the light changes its path and it refracts. Same thing is happening. In both the cases, refraction is happening. In one case, it's converging, in other case, it's diverging the light. And then, if you trace it back, it appears to meet and forms a virtual image. This is the basic what a lens is. So let me write down the definition of a lens. Lenses are pieces of spherical glasses or fiber that refracts the light by either converging it or diverging it. How they are actually refracting the light, on the basis of that, they are divided into two types. The first is convex lens and second is concave lens. You saw that one lens was actually converging the light. Converging, that means making it to meet, and another is diverging, that means spreading out the light. So it's like all the lights are moving away from each other, and this is the reason that convex lens is also known as converging lens, because it converges the light, whereas the concave lens is called diverging lens because it was diverging the light. So let me draw the diagram of each lens. This is convex lens and this is concave lens. If we talk about their structure, how can we define it? It's simply, if you look into the diagram of convex lens, from one end it's very thin, almost no thickness, then it start to become wider, and when it reaches to mid it becomes the widest, then again start to become thinner. So simply the structure of convex lenses, that it's like thinner at the ends and thicker at the middle, whereas concave lens is just opposite of it. That means it's thicker at the end and thinner at the middle part. The second difference is because convex lens converges the light, so it's also called converging lens, whereas concave lens diverges light and it's called diverging lens. So this is the basic definition where we have described its physical appearance as well as its purpose. Now let me see what is a ray diagram and what are the terms related to it and how can we draw it. A ray diagram helps us to know how the image will be formed, where the image will be formed, what will be the nature of an image if an object is placed at a certain distance from the lens. So that is the main purpose of a ray diagram. Now, in a ray diagram, there are few terms that are important. Let me understand those terms first. Principal focus. It's actually a point, as I told you, that the convex lens is the lens that converges the light. All the light that are falling on it, it converges and make them to meet at one point. Whereas the diverging lens, that is your concave lens, it diverges the light and scattered it, but it if you trace it backwards, it appears that they are meeting at one point. The principal focus is that point where all the lights are meeting or appears to meet. Let me just quickly draw this. Suppose this is a very rough diagram of a convex and this is a concave. All lights are falling on it, then it converges at one point. This is the point where they all are converging, called principal focus. Or if all the lights are falling on it, it diverges. If you trace it backwards, where all these are apparently meeting or appears to meet, this point is also called principal focus. So how can we describe it? So a point where all the light rays falling on the lens meet or appears to meet is called principal focus. Next is focal length. Let me draw the diagram for the better reference. So this is the diagram. This line that is passing through the mid of the lens, that is actually an imaginary line. Just like when we were doing reflection, the normal was, or in refraction, the normal was an imaginary line. Similarly here, this principal focus is also an imaginary line. But before that, the important thing here that you can see is a lens has two principal focus or two foci. Next is the focal length. Focal length, this is the lens and we consider this part. We measure distance from this middle part of the lens. The distance between the lens and the focus will give you the focal length. This will be actually your focal length. Third is the principal axis that I was talking about. So this imaginary line that is passing through the principal focus as well as it's passing through the lens. Next term is optical center. This center that you can see here, that I'm drawing this one, that is your optical center. Optical center is actually the middle part of the lens from where the principal axis passes, as well as it's the point from where the light will pass unaffected. Here if the light ray will pass, this light ray either it will, like, definitely it will converge. Here it will converge. In case of concave lens it will diverge. But when the light passes through this point, this, nothing will happen. No convergence, no divergence. It will go straight line, passing through a straight line unaffected. Now let me see the ray diagram. The first one is ray diagram of convex lens that we are doing. While drawing the ray diagram, we don't draw the structure of lens. Instead, we use a representation of it, which is like this. We represent the lens like this. This is convex lens. This one is concave lens. So whenever we draw a ray diagram, we always represent it with this one. This shows the convex lens and this shows a concave lens. We don't draw their structure properly. Now, as we are starting with ray diagrams of convex lens, the first thing is we have to draw principal axis. Next, we have to draw our convex lens. As I told you, it has two focus. It has two foci, F and F. If in the question it's mentioned that focal length is 3 cm or 4 cm, then you have to measure it. If they haven't mentioned anything about the focal length, only the question is draw the ray diagram when the object is at the principal focus or when the object is at 2F, then you have to take the focal length value on your own. You can pick any value, but whatever the value you are choosing, you have to measure the same distance on both the sides. If suppose you measured it to be 2 cm, that means 2 cm should be on this side as well. Next thing that you have to draw is called 2F, and its distance at twice the focal length. Just like if we have taken 2 cm as the focal length, then 2F will be at 4 cm. So in short, 2F is at twice the length. So these are the basics that you have to keep in mind. Next thing is It depends where the object is. We are taking case 1. Object is beyond 2f. You have to draw a line parallel to principal axis. It should be parallel to principal axis, first line, and then it passes through the principal focus. Once it reaches to your lens, then it will pass through principal focus. That means bend it so that it can pass through principal focus. That's your first line. Second line is this one. So I would recommend always the first line, this one, because it's much easier, and second is which goes undeviated through optical lens. So if you want to do 2 lines, I think this would be the best one for any sort of ray diagram on convex lens. So second line, you can see it passes through the optical lens undeviated. So we have to draw a straight line from the object passing through the optical center till it meets the previous ray. So wherever they are meeting will give you the answer. But I'm telling you the third ray, how can you draw? The third ray is, it will first pass through principal focus like this, and once it passes through the principal focus, it becomes parallel. It works just the opposite of your first ray. First ray was, it was parallel to principal axis, then it passed through the principal focus. This ray is, it first passes through principal focus. When it touches the lens or when it reaches the lens, it becomes parallel like this. And wherever these all three meet, you will get the answer, this one, because this point and from the principal axis we have to draw. This will be your image. And if you talk about the nature of this image, you can clearly see it's inverted, because object was upright, the image is inverted. Apart from that being inverted, it's diminished, it's a smaller in size. You can, if you're gonna compare them, it's a smaller in size. And what kind of image is it? Because it's formed by actual meeting of light rays, this is your real image. So how can you describe this? First, I need to write down the 3 steps that you have to follow while drawing a ray diagram. First is, it's real, inverted, smaller than object, and where it forms? Between f and 2f. Let me see the case 2. When object is at 2f, so as I told you, we can go for only 2 rays. So one ray parallel to principal axis and then passes to principal focus, and second ray that will pass through optical center undeviated. Where they meet, this will give you image at 2f. And if you see, the size is almost the same. So how can you describe the nature of the image? Real, inverted, equal in size that of object, and it will form at 2f. Now see the case 3. When object is between f and 2f. Now when the object is between f and 2f, same, we have to draw a line parallel to principal axis and then passes through focus, and a line undeviated through optical center. Wherever they meet, it forms an image, which is this. And you can clearly see the image is formed beyond 2f and it's comparatively larger than the object. So first is same, we can say real, inverted, larger than object, image is formed beyond 2f. Now the case 4, when the object is placed between the center and the principal focus. Here is our object. This is parallel to principal axis and then passes through focus. The second line is same, passing through the center undeviated. Clearly see they are not meeting at all. They are just diverging, going away. Like it's going away there, going away there. They cannot meet. There is a concept of virtual image comes where the image never forms by the actual meeting of the rays, but it appears that they are meeting at some point. So you just need to trace them backwards. Here, and they will meet somewhere here, and here your virtual image will be formed. This is your virtual image which will be formed on the same side of the lens. This is way more important. First is virtual, because it's not inverted, it's upright. It's definitely larger than the size of the object. And fourth one is it's formed on the same side of the lens. Next is diverging lens. Because it's a diverging lens, we are making this symbol. Here, say for example, the object is between 2F and F. We'll do the same thing. That means draw a line parallel to the principal axis, and once it reaches the lens, it will, instead passing through, it will just go the diverging rays. Instead of converging, it will diverge, but in the direction of this one. F is like this, so it will tracing the direction of F. If you join F and this in the same direction, you have to trace it. It will go like this. And the second ray is same, passing through optical center undeviated. Wherever they meet, for that you just need to trace that back. Here you will find the image. This should be dotted one. And this is the image, very small in size, you can clearly see. It's upright and virtual. So what kind of image is formed? Upright, virtual, smaller than the size, and formed between F and lens. So what are the steps you have to follow while drawing a ray diagram? You can clearly see if you have to write down the steps how to draw the diagram. It's simple. You have to draw a ray which is parallel to the principal axis, and then in a direction of F, it will diverge. You need to trace it back so that it can meet to the line to the second ray which passes through the optical center undeviated. Where they both meet, this will give you the image formed by the diverging lens. We have already seen this one. Let me take the another case where object is placed beyond 2F. If I place this object here, now same thing, I'll draw a line which is parallel to the principal axis. And then it will diverges, but in the direction of this one. This should be the direction. And you need to trace it here. This will give you the diverging ray. Second is it will pass through optical center undeviated. So this is the second line that will pass through undeviated. Here where they both are meeting will give you image, and you can clearly see that every time, doesn't matter wherever you are placing the object, the image is always formed between f and the lens, and it's always upright, virtual, and smaller than the size of the object. So that's it for today. In the next class, we'll be doing questions on the ray diagrams of converging and diverging lenses, and the questions are available on Akzsi app. The worksheet is there. You can just click on the link which is there in the description box, and also the organization code is there. You can download the app in your mobile and can access the free material. If you want to enroll yourself, or you want to book a demo for live online classes, one-on-one or group classes for year 1 to year 13, that means for GCSE A levels, KS1, KS2, KS3, just drop us an email at exacademy@gmail.com. So that's it for today. Thank you and have a great day. Bye.